In this video, we'll talk about ultrasonic sensors. And ultrasonic sensors are used to measure distance of nearby objects actually. So like a very practical application would be like say the system in your car, like say when you back into a parking spot. So you hear an alert, like say if you were close by other objects or like a wall or other cars. So that uses ultrasonic systems. So the way this works is the ultrasonic sensors would have a transmitter and a receiver. So the transmitter will send an ultrasonic pulse or like ultrasonic sound waves, and this travel through the air, and as soon as it hits an object, it bounces back, and then the other sensor or like the receiver receives this pulse, and then it kind of like, we know the speed of sound, and because of that we will be able to calculate the distance between the sensor and the object. So that is the theory behind this. So here we are using a sensor that is part of your package called HCSR04, and it has 4 pins. The first pin is VCC, which is the source voltage, so you can apply either 5 volts or 3.3 volts to the sensor. And then you also have 2 pins. One is the trigger, so this is used to trigger the emitter to produce ultrasonic wave. And then 3 is the echo, which will receive the information back. And then we have the ground, which will act as the reference for the entire sensor. So this is the way it works. So we will have to send a trigger pulse to the trigger pin. So this can typically last like for 100 microseconds. And when we say, so not 100, 10 microseconds, so as less, at least like 100 microseconds, and it could be longer than that, but again this is more than enough to trigger the ultrasonic sensor. My apologies, I'm kind of having troubles. I'm trying to open some files. So we are using the ultrasonic sensor. So this is what I was talking about. Like one would be the emitter and the other one would be the receiver, or the transmitter and the receiver. So the transmitter will transmit ultrasonic waves. So these are the pulses. So if it sees, or like if it hits an object, so it bounces back. The wave that bounced back would be received by the receiver, and then like that will be recorded as the output. And it will be sent to Arduino in this case actually. So here we are going to use a system like this. So we are going to connect 5 volts to VCC and ground to the ground pin. Then we are going to use pin 2 and 3 digital pins for echo and trigger. So here is the program. I'm going to open the file I sent you, or like which is available in Brightspace. I'm going to open that and connect the Arduino Uno. So once I just open this file, I will connect, or I will change the screen to the camera, and then like we will see how this will be executed. So here is the program we have, and let me share the connection. So here I'm not going to do too much. So here, this is the ultrasonic sensor, and then it has I'm taking 4 wires and then I have connected that to the sensor. But now I'm going to connect this to the let me peel this a little bit. I'm going to connect this to the Arduino Uno. So here again, as we told, we have the VCC pin, and then we have the trigger pin, the echo, and then we have the ground. So the yellow goes to 5 volts, then the brown goes to the ground. So that is done. And then we have pin 2 and 3 that goes to the echo and trigger pin. So I'm going to just do that connection at once. So trigger is in 3, yes, and then we have echo in 2. I'm just like checking, so let me share both. So this is what I was checking with. So what we'll do is we will set up like that. Probably I think instead of using that, you could also use you could probably connect it to the breadboard, then like it becomes easier instead of like say handling it like this. So I will let you decide on that. Maybe this is not a great idea. Okay, that should be good. I'm not going to be disturbing that. Okay, that should be good. Okay, so here let's look at the code here. The echo pin is 2, the trigger pin is 3. So here we have the duration and distance, so we will try to calculate that. Pin mode, trigger pin, I've set that as an output because we are going to trigger the sensor with that, and then we have the input which will be received in the echo pin. I'm using serial begin. I'm going to use serial monitor to communicate or get information from Arduino Uno. We have the digital write pin, which is set to low, and then for 10 microseconds. So here it is in microseconds. So for 2 microseconds, we delay, and then like we set it to high for 10 microseconds, and then here we are again putting it in low, and then we are going to check the pulse. So here's the echo pin, and if and we are setting or we are reading the pin when it is high. When does it read? And we are using a function called pulse in. Then if we this is a built-in function, you don't have to install any separate any new libraries. You don't have to add any new libraries to the Arduino IDE. So we use pulse in function. So what this gives is the duration of the pin. So it gives the duration, and then to calculate the distance, we use the formula duration times 0.034. So this is the speed of sound wave, speed of a sound wave. So, and we divide that by 2 because the sound actually goes from the sensor to the object, and then it bounces back. So when it bounces back, so it is so the actual distance is traveled twice to go and come back. So that's why we divide that by 2, and then like say we multiply it by the duration, and then we print the distance, and that distance will be in centimeters. And here's the delay. We do that every second, and then that information is received here in the serial monitor. So I'm going to run and see, so we don't have any issues. Compiling sketch, yes, done compiling. So maybe, I'm not sure like which one to use here. Maybe let's see, I will try to use my phone. And I need some kind of a support. Okay, so you can do the same. Better to put a flat object. It will literally do any object, but if it was like a flat object, it will be like much more accurate. And let's upload the program and see what we get. And then meanwhile, I'm going to use serial monitor as well. So the distance is 16 centimeters. That's what I get. So let's see. I will find a ruler. So here is a ruler. So let's see the distance between the sensor. No, I think you might not be able to see. So the sensor and... Okay, so... it is kind of 11 centimeters, that's what I would say. 11.5 or something like that. Yeah, again, so it's very close, so the accuracy is not too bad. And so it's like what we are getting somewhere between 14, 15. Yeah, so it's kind of reasonable, not too bad actually on the accuracy. So where it is getting reflected from, all those things does matter. So this is how we use an ultrasonic sensor to get the distance. So imagine now an application, a practical application. So if you put an object nearby, or like if you're parking your car, now you get how we can design a circuit and write a program to kind of alert the driver to kind of like maybe stop, don't go any further, like you are like maybe 30 centimeters away from hitting a wall or something like that. So you get that, I believe. So you can do like a lot of cool projects with this. And now let's see what assignment you have. So this is assignment question 3.13. Write a program to find the distance of a nearby object using an ultrasonic sensor and report its accuracy. So we'll have to place a flat object, so something like this, so 5 to 30 centimeters in front of the sensor, and compare the sensor's results with the ground truth. So that's what we did right now. So you will report the code, and then you will compare the results of the sensor and the actual data. So here sometimes we got 12, which was close, sometimes we got 14, 15. So probably like if you have like a perfect, so this is a weird case actually. So probably like if you use some object like which is really flat, you can do that and then like get some better results. The accuracy, I believe it is around like say 0.3 centimeters or something like that. So it's pretty accurate, not too bad actually. So and like I will also attach some photos or videos of this execution. And that will wind up the ultrasonic sensor. In the next video, we will see how to control a stepper motor using Arduino. See you in the next video.